Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Enjoy! So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. So for this frequency polygon, what we've got to do is work backwards to work out what the table was that created it. So we're going to just draw a starting of a table. And we're going to have our midpoint first, then our like money spent, our intervals, and then our frequency. So the first midpoint is at 40. And we can see here that that was, just get rid of that, that was between, like that was in this group here. So that is 0, and I'm just going to use M for money, 0 to 80. And the frequency is how high it is, which is 10. The next midpoint is here. So that was going to be 120. And we can see that that's between 80 and 160, and the frequency is 20. And finally the last midpoint is here, which is obviously 200, and that is between 160 and 240, and the height of it is going to be 7. So we're looking for the probability a customer spent less than 160, so that is these two here. Okay, so there are 30 that are less than 160. And how many are there altogether? Well, it's that 10 plus the 20 plus the 7. So it's going to be over 37. So it's 30 over 37. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us what can we cut all these pipes into, and they all have to be the same length that will fit with the 25 meter and the 35 meter. And essentially what this question's asking is what is the highest common factor of 25 and 35. So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5. And the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4. To scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage, and that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. To rearrange this, I'm just going to write out the equation again. and I'm going to put my lines in. Okay, so the first thing I'm going to do is try and make the x positive, because we're looking to make x the subject of the formula, which means we need it to be x equals. So what I'm going to do is just add x both sides. So we've got x plus m equals 10. Then we want to get rid of anything on the left hand side that's not this x. So we want to get rid of this plus m. So we're going to do that by subtracting m both sides. So we've got x equals 10 minus m. So our answer is 10 minus m. X equals 10 minus m. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. When we estimate, we normally round to one significant figure. So what I'm going to do is just rewrite this question, but rounding everything to one significant figure. But I'm just going to miss out this square root for now. So 3.3 would just be 3, and 4.7 would just be 5. Now, the problem with this 27 is square rooting 27 is difficult, especially without a calculator, and estimating should be done without a calculator. But if I round it to the nearest significant figure, if I round it to one significant figure, that will make it 30. Now 30 is no easier to work out. So square numbers are a bit of an exception. When you've got square root, it's a bit of an exception. You've got to find it to the nearest square number. So 27 to the nearest square number is 25. So square root of 25 is 5. And then 5 take away 3 is 2. Times 5 is going to be 10. So our answer is 10. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here. And obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down. And this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down. But here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31. And x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides. to get C on its own. So that would be minus 1 equals C. So C is minus 1. So we now know that the equation is y equals minus 2x minus 1. And we're told that the y is minus 37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be minus 36 equals minus 2x. I'm going to now times, or divide everything by minus 2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18, so the x value is 18 and the x value is the w value. So w is 18. To subtract mixed numbers, we must convert them into improper fractions first. So to do that, we do the big number times the bottom and add to the top. So it's going to be 3 times 4, which is 12, and add to the top, which is 15. Keep the bottom the same. 2 times 5, add to the top. So 2 times 5 is 10, add to the top is 11. Now we need to get the denominators the same. So the first number in the 4 and the 5 times table so we just write out the times tables and we can see that 20 is the first number in both of them. So we're going to times top and bottom of the first fraction by 5 and top and bottom of the second fraction by 4. So we must have the denominators the same to be able to add or subtract them, in this case subtract them. So when we do that, we get 75 over 20, and 11 times 4 is 44 over 20. Subtract the tops and we get 31 over 20. This is improper, so we can take away one lot of 20 from the top, which will give us 1 and 11 over 20, and that is actually our answer. We can rewrite this question as 2 over 1 divided by 1 over 15. Basically, when you've got an integer, which we do here, a whole number with 2, you can just write it as a fraction of that whole number over 1. Next we do keep, flip, change. We keep that first fraction, 2 over 1, change that divide sign to a times, and flip the second fraction. Multiply the tops, multiply the bottoms, and 30 over 1 is just the same as 30. So our answer is 30. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. So let's write these numbers out. And the first thing to do is work out what the numbers are going up by. So they're going up by minus 3, because they're minusing 3 each time. So we know that the number before the n is going to be minus 3. So whatever they go up in is the number before the n. Then what we do is we go backwards to find the 0th term. So actually going backwards, we would add 3 and we would find it to be 20. So whatever number's our 0th term, because 17 is our first term, is going to be what we add to the minus 3n. So it's going to be add 20. So our answer is minus 3n plus 20. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be minus 2. So what I'm going to do is I'm just going to put my rearranging lines in. And we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. First thing we notice is that there is a square here. So we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40. Which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these three here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600 take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1,600 divided by 4 is 400. So we're just cancelling the fraction and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves, so we'll have green on the left and brown on the right, so green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, so that's be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by minus 1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8, and 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it, so I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. So it'll be x to the power of 16. And then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the bottom or the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. We know that column vectors are shown with the amount right we go at the top and the amount up we go at the bottom. So we've got to work out how far right and how far up we go. So we're going to count the jumps from the start, which is at A. So 1, 2, 3, 4, 5 jumps right. So the top of our column vector is going to be 5. And 1, 2, 3 down. Now, because it's down, it's going to be minus, and we've got 3 down. So it's 5 at the top and minus 3 at the bottom. So here we're just adding the column vectors. So we're going to add the tops, so 2 plus the 5, and we're going to add the bottoms, minus 4 plus 6. 2 plus 5 is 7, minus 4 plus 6 is 2. So our answer will be 7, 2. Here we notice with the simultaneous equations, the coefficients of the x are different and the coefficients of the y are different. But if you look at the coefficients of the y, they are similar, because we've got a plus 4 here and a plus 8 here. So all we need to do is multiply the top one by 2. So we're going to do 2x plus 4y equals 2. And we're just going to multiply all of the terms here by 2 to get that second term, the 4y, to make it equal to 8y. So that's going to be 4x plus 8y equals 4. Then I'm just going to write out that equation we've just worked out, and then write out the second equation underneath. And now we have the same coefficients. So if we put in our circles, because obviously with simultaneous equations we work downwards, and we look at the signs now before the 8y's. So we've got a plus and a plus. Well, if they're the same signs, we subtract going downwards. If they are different signs, we add going downwards. The D in different, the D in add, the S in same, the S in subtract. Well, they're both pluses, so we're going to subtract. And so we're going to have 4x take away 3x, which is just x, 8y minus plus, which is just minus, so 8y minus 8y, which is 0, which was good. So that's the whole point, is to get rid of those y's. And we've got 4 take away 7, which is minus 3. So x is minus 3. Now we can't stop there because we need to find out what y is. So we substitute in the value of x, which is minus 3, into our first equation. So 2 times minus 3 plus 4y equals 2. We get our lines in to be able to solve it. So first thing I'm going to do, well, 2 times minus 3 is minus 6. So we're going to add 6 both sides. And so we've got 4y equals 8. Then we're going to divide that 4 from both sides. So we've got y equals 2. We can check this by putting the values of x and y, substitute them into the second one. So 3 times minus 3 plus 8 times 2, and that does equal 7. This question is the same as questions you get where you've got y equals 8x squared, and you've asked to find what y is when x equals 3. The questions are exactly the same, but instead of y we write f of x. And this is saying that the function is 8x squared, and we want to feed in the 3 into the function. So it's going to be 8 times 3 squared, and 3 squared is 9, and 8 times 9 is 72. So the answer would be 72. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the medium, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, And normally we just put a little kind of line at the end here. So we're going to put a line at 1. And I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11. So we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. So sometimes it's easier just to do a quick diagram to see what's going on. So I'm going to say that the house is here and the shop is here. And so this person is walking to the shop and then they walk back from the shop, but they don't walk as much. And we're looking to see the maximum distance the person is from their house. So we're looking to maximize this distance here. So we want this distance to be the biggest it can be. So we can see that we want to maximize this distance here, so that the shop is a long way away. And we want to minimize this distance here because we don't want them to have made that much distance towards their house, because we want to maximize that distance. So we're going to find the maximum for the 3,750. So it's to the nearest 10. And a trick you can do to find out what the upper bound is going to be is just half the accuracy. So 10 meters to the nearest 10, half of that would be 5. And then just add that on. So that's going to be 3, 6, 5, 5. That's the upper limit. We want to minimize this distance, which is 120. So the accuracy is still 10 because it says both measurements are to the nearest 10 meters. So we're going to halve that accuracy. 10 would be 5. And this time we're going to take it away. So 120 take away 5 would be 115. Okay, so to find the maximum distance the person is from their house, we're just going to do 3,655 take away 115, which will equal 3,540. So the first thing we need to do is factorise the quadratic on the left hand side. So we'll end up with the quadratic equals 0. And one of the ways of doing that is multiplying the coefficient x squared by the number on its own at the end. And we're looking for two numbers that multiply together to make that number. Well, that's just going to be 6. And we're looking for those same two numbers to add together to make the 5 there, coefficient of the x. So two numbers that times together to make 6 and add together to make 5 are obviously going to be 2 and 3. And we're just going to rewrite the quadratic, but instead of the plus 5x, we're going to write plus 3x plus 2x, or the other way around. Doesn't matter which way around. Then we're going to factorise linearly the first couple of terms, and then do exactly the same thing, factorise the second two terms. So when we factorise the first two terms, we can divide out a 3x from both of them, and that leaves 2x plus 1. And for the second two terms, we actually can't factorise anything. Well, we can factorise a 1, that's what we'll do. and the repeating bracket is the second bracket, and then the bits on the outside come together to make our first bracket. So our brackets are 3x plus 1, 2x plus 1. What we do now is get both of the brackets equal to 0, and we solve. And that will give us both our solutions. So get our lines in. And we'll first of all take away 1 from both sides, so we get 3x equals minus 1. And then we're going to divide by 3 both sides. And we're asked to leave this as a fraction, so that would be minus 1/3. And that will be our first solution. Do exactly the same thing to the other side. So we've got 2x plus 1 equals 0. Get our solving lines in. Subtract 1 both sides and you get 2x equals minus 1. And then we're going to divide that 2 from both sides. We get x equals minus 1/2. The first thing to notice is we actually have 2 radii here. So we've got this radius here and this radius here. And all radii are always equal in length. So we have an isosceles triangle here. So this angle here is going to be 19x as well. And we've got to write that down. So we're going to say angle OBA is equal to 19x. And the reason is it's an isosceles triangle. Okay, so we know these two are equal. Well, we also can work out x because, as I said before, we have a triangle here. And all angles in a triangle add up to 180. So we've got 7x plus 19x plus 19x equals 180 degrees. And this is angles in a triangle. Try and draw a better triangle, equal 180 degrees. Try and write out these reasons in full. Okay, so that's going to be, was it 45x equals 180. And let's get our solving lines in. And we're just going to divide both sides by 45. Okay, so we've got x equals 180 divided by 45, which is 4. Now, we're looking for this angle here. That's angle ABC. Now, there's a few different ways we could do this. We could work out what this angle is, because it's a big triangle, etc., etc. Or we can use the fact that we've got a tangent touching a radius. So we know that this, let's just pick a different colour, this angle here is 90 degrees. So we can write that down. So angle OBC equals 90 degrees because it's the angle between a tangent and a radius. Again, make sure you write all the reasons in full. And so therefore, angle ABC, which is what we're asked for, it's just 90 take away the 19x. Well, we know that 19x is 19 times 4, because we know that x is 4. And so that would be 76, so in total it would be 14 degrees. So angle ABC is 14 degrees. So we're going to go through one way in which you can do this question. With circle theorems, often there are multiple different approaches, and so if you do a slightly different method, but you've written down all the working and you're happy with it, and you get the same answer, it's probably fine. Just don't forget with these, always show every step of your working out, because normally, say there's 3 marks for this question, 1 will be for the answer and 2 will be for the working out. So the first thing I notice with this question is that we have a lovely triangle coming off a tangent, and whenever we have that, the angle on the outside here is equal to the angle on the opposite side of the triangle. So this is going to be 44 here. I'm just going to remove all of that, and so this is going to be 44 degrees here. So angle BFD equals 44 degrees, and the reason you need to give is the alternate segment theorem. And you have to use those words, otherwise you won't get the marks. Now, next I notice that we've got a set of parallel lines here, and we've got a line going through them, and so the 44 degrees there is going to be equal to this one here, and so this is going to be 44 degrees. So we say angle FDE equals 44 degrees, and the reason this time is alternate angles, put the E in, angles, and again you have to use the word alternate. Okay, next thing I notice is that we have an isosceles triangle here, here and here, and the bottom two angles in isosceles, assuming that it's upright, are always equal. So this is going to be 44 degrees here, so angle EFD is also 44 degrees, and again we have to just say that it's an isosceles triangle. Okay, just highlight the fact it's an isosceles triangle. Okay, next thing we're going to work out is this one here, and it's just angles in a triangle. So angle FED is going to be 180, take away the 44 plus the 44, and the reason is angles in a triangle add up to 180 degrees, and so 180 take away the 44 plus the 44 is 92 degrees. And finally, took us a while to get there, but finally we can work out what this angle is, because in total all four corners of this quadrilateral here are touching the circle, so it's a cyclic quadrilateral. And so angle, what's it called in the question, angle FBD is going to equal 180 take away 92, and again we have to show the reason of the fact it's a cyclic quadrilateral. And so 180 take away 92 is going to be 88 degrees. So our answer will be 88 degrees. I'm going to start by getting x equal to the 0.847 recurring. And I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is, and that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000, we'll find out 1,000x, and so it would be 847.4747, etc., etc. Next, I'm going to take away everything. So 1000x take away 10x, and that's going to be 990x, and then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. When asked to simplify an algebraic fraction, you will almost always need to factorise either the numerator, the denominator, or both. On this question, we need to factorise both. So I'm going to start off by factorising the top. Now you'll notice that this is a difference of 2 squared, so this is nice and easy to factorise because it will be x plus 2 and x minus 2. And we've got loads of videos on how to identify and deal with difference of 2 squareds if you don't know how to do that. Similarly, the bottom is just a simple quadratic, so we're just going to factorise that. Again, we've got videos on how to factorise quadratics, so have a look at those if you need to. Then we're going to look at top and bottom and see if there's a bracket that's the same, which there is, this x minus 2. So we're going to divide top and bottom by x minus 2, and that will effectively get rid of the x minus 2 at the top and the x minus 2 at the bottom. It won't get rid of it, it will just turn it to 1, and then it will be x plus 2 times 1 and 2x minus 3 times 1, which will just be x plus 2 as the numerator and 2x minus 3 as the denominator. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. So for this question, first thing to notice is there's a divide there, and we can actually just write this as a fraction. So 10 plus root 2 over 14 plus root 2. We'll keep the brackets there. We don't need them when it's in a fraction, but it will help us for the next step. So we're asked to transport this or change this into a fraction without a surd at the bottom. And so it's basically asking us to rationalise the denominator. Now, when you have two terms, including a surd at the bottom, we need to do something a bit special with this. And the thing we do is we times it by the opposite bracket. And what I mean by that is if it's 14 plus root 2, we times it by 14 minus root 2. And we've got to do the same to the top. And the reason for that is essentially here all we're doing is we're timesing it by 1, because 14 minus root 2 over 14 minus root 2 is just 1. So we're timesing it by 1, so we're not changing the fraction at all. Okay, let's draw a grid to work out what that will equal. And you can use any method you want. You can use double smiles and rainbows, FOIL, whatever method you have to multiply two such brackets. I'm going to start off with the top. The top is 10 plus root 2 times 14 minus root 2. So 14 times 10 is 140. 14 times root 2 is just 14 root 2. 10 times minus root 2 is minus 10 root 2. And then a minus and a positive make a minus, and root 2 times root 2 is just 2. Now, when you expand surdy brackets, these two and these two will add together. Okay, so we're going to start off with the numbers. 140 take away 2 is 138. And then we'll do the surd. So 14 root 2 take away 10 root 2 is plus 4 root 2. Okay, so the top is going to be 138 plus 4 root 2. And let's do the bottom. And I like these grids because you can see if you've made any mistakes quite quickly with these. You can check your working. So 14 plus root 2 times 14 minus root 2. You'll see why in a second we do the opposite. So 14 times 14 is 196. 14 root 2 minus 14 root 2 and then minus 2. So you can see here now there's a 14 root 2 plus minus a 14 root 2. Let's just cancel each other out to 0. So we get rid of the surd. and then 196 take away 2, which is 194. So we've got 194 at the bottom. Now something we notice here is that all the terms in the fraction are even, therefore we can halve everything. So 138 halved is 69, 4 root 2 halved is 2 root 2, and 194 halved is 97. And so that would be 69 there, and that would be 2, and then that would be 97. So we're going to just quickly write out our sequence, so 9, 22, 41, 66, and 97. And we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19. So they're different already, we know that it's not a linear sequence. And that's going to be plus 31. So we now look at the difference of the differences. And so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence. And we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important, because that is the coefficient of the n squared. So we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth, and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66, and 97. Now, we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3. 3 times 2 squared, which will be 12. And then 3 times 3 squared, 27. 3 times 4 squared, 48. 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit, because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now, what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. When we have a times 2 inside the function, so it's 2x, it actually does the inverse to the x coordinate. So it actually divides all the x coordinates by 2. So if we see this coordinate here, which is what, 2, 3, that will now become 1, 3 on our graph. Okay, and this one here is at minus 2, 3, that will be minus 1, 3. And similar to all of these points, so we're just dividing each of the coordinates by 2. We're halving each of the coordinates. And so what you'll end up with, and we're just going to try and roughly sketch this out. It's not going to be perfect, but there's a graph that looks something like this. It will still cross the y-axis at the same point, and then we're going down to about here, back up again, and somewhere there. I reckon I could probably do that a little bit better, maybe, I don't know. And this isn't supposed to be perfect, but the examiner can clearly see that I've halved all the x coordinates. So we're going to start by completing the square, which it's asked us to do. And so to complete the square, what we do is we put a set of brackets down, and we put x minus half of the coefficient of the x, so minus 5. and square it. And if you were to expand that, you get x squared, brilliant, minus 10x, fantastic, plus 25. So we need to remove that 25. And then we've got the minus 11 there, just that was on the end there. When you tidy that up, you get minus 36. Okay. Now I'm going to draw the graph of y equals x squared. Oh, I'm going to sketch it. It will look something like that. Probably a bit of a curvier bottom on that. Let's try again. So let's go curve at the bottom and go up like that. Okay. And the bottom of it, this part here, is at the coordinate 0, 0. Okay. Now, we remember, hopefully, from graphic transformations, is if you have got a minus 5 on the inside of a function, and if we imagine that this is our f of x, then this would be our f of brackets x minus 5, because it's got the minus 5 there. We move the graph to the right 5. Remember, it goes the opposite way. So if it's a minus 5, it goes to the right. If it's a plus 5, it would go to the left. We also know that if you have a minus 36 on the outside, which we do here, it moves it down 36. So it's going to go down 36. So our new minimum point won't be at 0, 0. It will move to the right 5. So the x coordinate will be 5. And it will be moved down 36. So it will be minus 36. So I'm going to, first of all, just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, and I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. And that's why it's a nice, easy way to show that A to M is 1/5 of that distance. And let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.